This is Mr. Yeager for chemistry. We are looking at phase diagrams. This is again kind of continuing with the states of matter stuff in terms of, like we said, we're going to be having to analyze different types of graphs, and this is one of the graphs we're going to be looking at. But it's a pretty straightforward graph, and we're going to just be kind of looking at it going, you know, what's happening based on the graph. Are we changing from solid to liquid? You're going to have to identify the phase. You're going to have to identify the phase change. And then there's a couple other little extra things we learn with the phase diagram as well. So there you go. This says watching a video clip. There is a video that is attached to this presentation if you have access to it, so that you could watch that as well, so that you can watch somebody else doing it, but I'm going to do it. But we're looking at what is the phase, what is a phase diagram? What is the phase diagram used? What do the lines represent? What are the parts of the phase diagram? So here we go. Skipping all that. So I'm going to do it. So this is your general phase change diagram. Okay. What you should notice first off is we should look at the axes. We have pressure on the y-axis and we have temperature on the x-axis. All right. So as I go up the y-axis, the pressure is increasing. In other words, I'm trying to push those particles more and more and more together. I'm trying to compress them as much as I can. Okay, if I can. If I go from left to right, the temperature is increasing, which means the particles are starting to move faster and faster and faster. Okay? All phase change diagrams basically have this type of look, where you have some sort of line at the bottom coming up to a point, and then you almost get this V or U shape created. Okay? This V or U shape. This, I'm going to draw another one over here. It's perfectly fine to see it kind of look like this, where it goes backwards some. That's okay. But in all of these, we always write out the states of matter are always in the same spots. The solid is always on the left-hand side. The liquid is always in between the V or the U. And the gas is always on the right-hand side. All right? And so the first thing to kind of understand there is, if I give you a data point, and I say, you have this temperature and this pressure, and you end up somewhere over in this giant section over here, any data point that you get over here, all I'd be asking is, what state of matter are you? And you'd be saying, I'm a solid. If my data point lands in this middle section, you would say, I'm in a liquid state. If you land over on the right-hand side, that means you are a gas. So that's all you're basically saying is, I will give you a temperature and a pressure, and you just got to be able to line up those two spots and go, where are you? And that would be representing the phase that you are. Okay? Now, a little bit about these lines. We have to understand what the borders represent. Okay? Well, this border right here that I'm drawing on is between solid and liquid. So if I travel from the solid and cross this border into liquid, what has happened? A phase change. And then what phase change has occurred? That would be melting. Solid to liquid is melting. If the problem, I start on the liquid side and I say I move back to across the border into the solid, that means I am freezing. Okay? So the border between solid and liquid is obviously your melting freezing point line. Okay? Your melting freezing area. All right? The line over on the other side is obviously bordering liquid and gas. So if I cross it from liquid to gas, I'm boiling or vaporizing. If I pass it from gas to liquid, I am condensing. All right? So again, we just need to know our state changes. That's all that you're basically doing here. And again, I will give you 1 point and go, you now change the temperature to this. You change the pressure to this. Understand, look at this. If I have a liquid and I decrease the pressure enough, guess what's going to happen? I'm going to change to gas. And that means when I hit this point, my substance starts to boil. Which is always a weird thing. I mean, it's a really cool thing to see. I wish we had the ability to kind of show water in a vacuum and you'll see it bubbling, okay? Because if you don't have any pressure on it, the particles don't need to stay together, the liquid particles don't need to stay together, and they spread out and they boil at a very low temperature, okay? So that's what we got with the border. The border represents state changes. I didn't go over the border at the bottom. The border at the bottom is also a state change, but you're going solid to gas. So you need to remember sublimation. You need to remember deposition. Okay? So that would be what's occurring if you're crossing at the bottom barrier there and you never touch liquid. All right, so what else do I have here? A couple of other important points. All right, it's not, oh, I guess it is on this one. This one's not very good. I'll do that one in another one. Let's just talk about the other spots here. There's two important points. There's technically four. We'll get to four, but there's 2 points I can show you on this one, and then I'm going to have to make another one. This point right at the bottom here that I'm coloring in, and it has the dotted line there, all right, coming from the pressure and the temperature. This point here where all three phases are meeting up, well, guess what? We call that the triple point. Because there's triple states. There's solid, liquid, and gas all present at that temperature and pressure. I have never seen that. It would be a very interesting thing, but all three states of matter would be existing at the exact same time, okay? And what would happen is they'd be boiling, they'd be condensing, they'd be freezing, they'd be melting. All four state changes are occurring at the exact same times. They'd even be sublimating and deposing, okay? So that's called a triple point. The other point is at the very, very edge of the curve, and usually this is kind of clearly drawn in as a dot as well, and sometimes there's even a dotted line that keeps going up. This point at the very edge here between liquid and gas of that curve is called the critical point. It is the critical point. The critical point is basically saying this is the temperature where you are now always a gas. Okay? All right, don't worry about the supercritical fluid. I'm not worried about that. All right, temperature, basically when you reach this temperature, so whatever the substance this is, they're saying at 31.1 degrees, it doesn't matter how much pressure you put on this, it's moving so fast, this substance is moving so fast, it can never ever change back into it will not change into any other state, even if you keep on applying more and more pressure to it. All right? You will maintain a gas. Now, obviously, if you lower that temperature, then yes, you can become liquid again. But we're saying if you're at this temperature or higher, you are always a gas, and that you have passed the critical point. Now, the only other thing I can think about, I'm not worried about that. The only other thing to kind of point out that you do have some questions sometimes on your papers is they might go, what is the normal melting point and normal boiling point? We call it normal. The normal melting point and boiling point occur at 1 atm pressure. So we said this side is pressure, this side is temperature. If you're ever asked what is the normal melting point, and we know this is solid, liquid, gas, what you do is you find where 1 atm is on the y-axis, and you go over to the border. You would then go down and record this temperature. This would be the melting point temperature. That would be the normal melting point. For the boiling point, you would just keep going to the liquid gas barrier and go down, and that would be your boiling point temperature. So the normal boiling point, normal melting point is specifically at 1 atm for any substance, and you just cross over to the border between solid and liquid for melting, liquid to gas for boiling, and go straight down and record what the temperature is. And that's it. That's how you deal with phase diagrams. All right? Good job.